Good afternoon.
And yes, sir. Good afternoon. This is Sridatta from IGBC. So we'll just wait for a couple more minutes and we'll start. Hello, Silva.
How are you?
Good afternoon, sir.
Current portal. Good afternoon, everyone. Can you hear me?
Yes, sir.
Okay. Yeah. So, Sambat, please tell me when we can start. We start then.
Yeah, just Sridatta? Yes, Sampath sir, I'm here. So we'll just waiting for a couple of more participants to join in. So
Okay, we'll
start
wait.
in 3 more minutes.
Okay, right.
Okay, thank you. Good afternoon, everyone. So, sir, I think we can start. It's already 3:05.
Okay.
So, I would like to just welcome all the participants to the day 5 of the webinar series. So, past 4 days we have covered on energy, building efficiencies, and incorporating renewable energy materials in the buildings, and also urban designing with latest trends and technologies. So today we will be talking about net zero building design planning for carbon neutral future. So speakers for the day are Mr. Sampath, Mr. Harish, and Mr. Selvarasu. So I would like to introduce architect Venkatesh Pai. So he is the chairman for IGBC Mangalore chapter and principal architect at Milan Architects. So with 25 years of experience in design to the practice and belief in the industry of sustainability. So he has been with IGBC in lot of activities. And currently he is also the chairman of Indian Institute of Architects, Mangalore Manipal Center. So he is a graduate at MIT Manipal. So, sir, welcome to the webinar. I would like you to do the welcome address and set the tone for the today's webinar.
Thank you, Sampath. Am I clear?
Yes, sir, you are audible, please.
Okay. Welcome, dear friends. A very good afternoon and warm welcome to the day 5 of this interesting webinar series organized as a part of the World Green Building Week 2024 celebrations. It's an absolute honor to be with you today as we delve into one of the most pressing issues of our time, net zero building design and planning for a carbon neutral future. The building sector, as you know, plays a critical role in India's journey towards achieving a net zero emissions by the year 2010. The buildings are generally is considered to be responsible for about approximately 40% of global carbon emissions. So achieving net zero in this sector is essential if we have to meet our targets. Well, this kind of transformation is not just about technology or policy. It's about leadership, innovation, and collaboration at every level. So I encourage everyone here to participate actively, to ask questions, and to think critically about how ideas presented here can be applied in your own work, in communities, and in projects. As we begin this journey towards the carbon neutral future, you must remember that this is not just an environmentally imperative issue, it's also an economic and a social one. Net zero buildings offer amazing potential for reducing operation costs, improving occupant well-being, and enhancing the resilience of our cities. So I would say we should use today as a springboard for action, not only in the planning, also to execute strategies that will pave way for a more green future for us, a more sustainable world. Thank you again once again for being here today and for your commitment to building a carbon neutral future. Let's get started. With this context, let me introduce you to the speakers of the season of this particular session. We are honored to have with us distinguished speakers who bring with them a wealth of expertise in their field. Mr. Sampath Kumar is a senior counselor CI IGBC. He'll be from the IGBC side. Mr. Selvarasu, who is the managing director of Lead Consultancy and Engineering Services India Private Limited. Mr. Harish Bora, principal life cycle analysis and expert in ADWA developments. I'm confident that the presentations will inspire us to think deeply about the challenges we face and the solutions we need to implement for a carbon neutral future. So, gentlemen, ladies, let's take this opportunity to engage, learn, and collaborate for a more sustainable tomorrow. Thank you.
Thank you, sir. Thank you for the wonderful welcome remarks and setting up the tone for the day. So, without any further ado, I would like to introduce the first speaker of the day, Mr. Sampath Kumar. So, he's a senior counselor at IGBC and has been working with IGBC since 2007. Who here is leading IGBC's mission on net zero initiatives. And he has been with IGBC developing a lot of rating systems, capacity building activities, and representing IGBC at World Green Building Council. He's a civil engineer from Osmania University with post-graduation from NICMAR, National Institute of Construction Management and Research. So, Mr. Sampath, sir, I would like to hand over the stage to you.
Yeah, thank you, Sridhar. Let me share my screen. Is the screen visible, Sridhar?
Yes, it's visible.
Yes, this is good.
Yeah, thank you, sir. Yeah, thank you so much, all the participants. A very good afternoon to all of you. I would take about 15-20 minutes to brief what is IGBC's approach for net zero carbon buildings and built environment. Yeah, you might have seen this slide a lot. Many times, the green building movement, which was initiated from our center in Hyderabad in the year 2001 with about 20,000 square feet. But today we have close to 12 billion square feet of projects with more than 1,400 projects. But what I want to emphasize is over the last 3 to 5 years, we started receiving many of the projects under net zero also. Many of these are pilots. We have 100 plus projects, and it's a beginning and a long way to go. We expect many more projects to become net zero in many ways, in terms of energy, water, waste, and carbon. And as I just mentioned, over the last 2 decades, we have worked on several building typologies, whether in office, residential projects, or airports, convention centers, or factory buildings. Quite a lot of buildings which we have covered, and of course we emphasized on the built environment, that is townships, large campuses, cities. So we with the experience which we gained from buildings and built environment, we believe that we are well positioned to embark on a journey on a net zero. In fact, Indian Green Building Council is one of the first few councils to start the thought process way back in 2016, when all of us were discussing what is net zero, but how it can be defined. But we started our journey, and we launched IGBC's mission on net zero in the year 2021 with a vision to facilitate India to become one of the foremost countries in transforming to net zero by 2050, because we thought we should go on a mission mode. And it's not just the carbon or energy, which quite a few countries or organizations are working. We thought it should be a journey in all aspects, that is energy, water, waste, that is resources, and carbon. So many of the organizations have come forward and committed to achieve the net zero status for the new and existing buildings. And most of our time now, we are spending time in terms of facilitating or handholding these projects, how to create their roadmaps to achieve the net zero status. And what is more important is we work with World Green Building Council and many of the councils across the world. Being one of the founding members of World Green Building Council, we are fully aligned with the vision of WGBC, which is whole life a carbon vision by 2050, where all the buildings, both existing and new, will be net zero carbon, both in terms of embodied carbon and operational carbon. Having said this, we have worked on the net zero rating systems exclusively, wherein we are trying to define the criteria for each of these categories, that is energy, water, waste, and carbon, so that the projects can explore the net zero based on the priorities or applicability for the respective projects, and achieve one of these or a combination of these rating systems, and ultimately work towards a net zero carbon. And what we also believe is there's a nexus between energy, water, and waste, which ultimately results in a net zero carbon status. And so we are fully committed to work with the projects and organizations to transit them to net zero and achieve the net zero carbon status ultimately. So having said this, let me dwell a bit more on net zero carbon. In the year 2020, One, we have come up with a net zero guidance framework wherein we try to understand how net zero carbon is perceived globally and what are the ways and means to achieve the net zero carbon status. And after 2 years, in the year 2023, we launched our pilot version, net zero carbon rating system, wherein with the support of the stakeholders, we have defined the definition of a net zero carbon, which is the net zero carbon buildings are highly resource efficient and offsets direct and indirect carbon emissions in account of its design, construction, and operation. So this is what the consensus which we have come with the support of the stakeholders and industry experts. And my other panelists, Mr. Selvaraju and Harish Bora, were also on the committee sharing their views in and developing this rating system. I take this opportunity to thank both of them for their valuable inputs before and after the development of this tool. And in terms of approach, what we thought is we should look at projects both in design and construction phase and operation phase, but should be a step-by-step approach. So what we thought is for design and construction phase, we should emphasize a lot on embodied carbon, and of course a roadmap for the operational carbon. Whereas in operations phase, we look at operational carbon. So and moreover, what we thought is the net zero carbon is with respect to buildings and the associated carbon emissions with the concerned environment. What we mean this is anything related to the building operations is what we take into account. So if I have to tell in other words, it is predominantly the scope 1 and 2, which we are trying to focus presently based on the pilot version approach. And moving on, we want the projects to look at the whole building life cycle analysis as per the criteria which we have defined in the rating system, wherein we intend the projects to perform whole building life cycle analysis to estimate the carbon emissions as per ISO standard 14040 and EN 15978 standard, which is known in the market, which defines the project stages. So we are looking both embodied carbon and operational carbon, as I mentioned, for the design projects. But at the same time, we are not trying to cover all stages. We thought the market should evolve and understand, and more importantly, how to go about the embodied carbon with respect to the data sets. So we thought we'll look at embodied carbon in LCA stages of A1 to A4, and then operational carbon predominantly with B6, including the water, which is converted into energy. So that's what we're looking at in the pilot version. And then more importantly, we thought it's not just the carbon, but as mentioned earlier, there's access between energy, water, and the resources which were used. So we thought we will have a integrated approach to net zero carbon. So as part of the mandatory criteria, we're emphasizing on energy performance ratio, water performance ratio, and how the project is managing the waste with respect to the organic and the dry waste. And do the project has a procurement policy, a green procurement policy, so that whatever the materials which are being sourced are sourced in a sustainable way. So let me delve very quickly on this. As many of you may be aware about energy performance index ratio, which is defined in the energy codes, whether it is IGBC or ASHRAE 90.1. So EPI ratio is nothing but EPI of a proposed building vis-a-vis a standard building, wherein we look at a prescriptive approach or a whole building simulation approach. But what we're trying to say, whether it is a prescriptive or a whole building, the EPIs which are defined as per the standard or as defined by the BE will be taken as a standard building, and whatever the proposed case is what actually the building has a EPI or the EPI which is derived from the energy simulation. So this EPI ratio should be lower than 1. I mean, if it is higher than 1, that means if the building is inefficient, and a mandatory requirement is EPI should be 0.95 or lower. So such projects only would be accepted for net zero carbon. The intent here is the projects may offset all the carbon through renewable energy sources. But what we are looking at is the energy efficiency, the energy performance, as well as the energy demand also should be taken into consideration. Similarly, we are looking at a water performance ratio. So water evaporation ratio is defined as altered water consumption towards the total water consumption. Altered water is any water which is like treated wastewater or stored rainwater, condensate water, or even water which is sourced through tankers or piped connection as a grey water is what we are drinking at altered water. So what we are trying to say is the project is recycling the water and using as much of the water which is within the premises. So we're looking at the circularity as a concept here and how we can achieve by reducing the water demand and harnessing the altered water. And then green procurement for say design-based projects, we emphasize mostly on the construction-related materials. So we're encouraging the projects to have eco-label products or use salvage products, rapidly renewable products, materials with high recycled content, or alternative products like M-sand, and then upcycling in terms of the use of construction waste. Materials which are made of construction waste and demolition waste is what we're trying to emphasize through green procurement in design. Whereas in operations, we're looking at biodegradable materials, like for example, trash bins or eco-friendly housekeeping chemicals, use of recycled papers, banning single-use plastic. So the policies can be looked from the organization so that the material sourced for the operations are environmental friendly. And then with respect to the projects in terms of the design and construction phase for net zero carbon, as mentioned earlier, we are focusing on embodied carbon, and with the consensus and the industry practices both globally in India, we thought we should benchmark because we can't make embodied carbon zero considering the present context. So we are trying to encourage projects to use low embodied carbon materials. And herein, we are looking at civil materials to start with, because these are the ones which have higher embodied carbon. To name a few, like concrete, steel, glass, aluminium, these are the ones which have higher embodied carbon. And civil materials and interior materials, if you look at in all, 80% of the embodied carbon comes predominantly for civil materials. And we also reserved the MEP products or technologies or solutions for now aside. So the emphasis is more on civil materials, as the data set for these materials is quite possible. So in that context, we have arrived at 700 kgs of CO2 per a square meter. And this is related to the stages from A1 to A4. And this number, we have studied globally what are the benchmarks, particularly in the Europe context. And we also did some study as pilots in India, the LC analysis which was carried out. And we thought the embodied carbon benchmark should be an acceptable benchmark, which should not be an entry barrier. So it is, the intent here is to more and more projects to do the LC analysis. I mean, are we at 700? Are we at 1,000? Are we at 500? This is what is not known to most of the projects. So the intent is to drive the projects to do the LC analysis, create awareness, how to use these LCA softwares, have more and more experts who can facilitate the projects in deriving at the embodied carbon number. So that's what we're working with the experts. On the other side, we're working with the manufacturers, how they can define the embodied carbon for those materials so that these are accessible and available for the projects to use. In terms of operational carbon, I mean, of course, though the project's in design stage, we want the projects to figure out, or estimate what is the annual energy consumption when the project's in operation. So what we are recommending the projects is to do the energy simulation analysis and then convert the energy consumed through conversion factors into the operational carbon. And then what is the roadmap to offset this operational carbon, whether it could be onset or offset renewable energy sources or the carbon sequestration measures. So the roadmap is very important. A lot of the projects are emphasizing that, we are putting efforts to embodied carbon, but what is that we need to do to offset the operational carbon? So we are encouraging the projects to have policies so that they can source more renewable energy to offset the operational carbon, and more importantly, see how they can reduce the energy demand so that the overall energy consumption itself can be reduced. To give one example, for example, a project which uses a single glazed glass for, say, envelope, the embodied carbon of single glaze may be lower, but on during the operations, due to the radiation, the more heat gain would be there in the project, and the cooling loads will increase because of a single glaze, probably an inefficient glass. But say if we are converting the single glaze glass to a double glaze glass, the embodied carbon certainly would be higher for a double glazed glass, but what could be the relative reduction for the operational carbon? So the point we are trying to emphasize is project should focus both on embodied carbon and operational carbon while identifying the materials and accordingly choose the products. And some of the strategies to reduce the embodied carbon, the first and foremost is how we can optimize the structural design. So this would significantly reduce the use of resources, particularly concrete, steel, which can reduce the overall loads in the building. And then, of course, sourcing local materials can significantly reduce the carbon emissions resulting from the transportation. And having sourced a high recycled content materials or recyclable materials also will help the project in reducing the embodied carbon. And alternate materials like slag cement or the flash based blocks, which can be used to reduce the embodied carbon, because we are not using the virgin materials, which will increase the overall embodied carbon of the materials. So we have come up with a checklist. I will not dwell in detail. This was basically to give an overview. So we have come up with a checklist wherein the projects have to do a whole building life cycle analysis in design and construction phase, emphasis on a green procurement, and have strategies to reduce the embodied carbon with the integrated approach as we just discussed. So on a scale of 100, the project needs to demonstrate compliance. So we have come up with near net zero and net zero recognitions for design, wherein the projects have to comply the benchmark of embodied carbon for 700 kgs or lower per square meter, and then offset at least 75% of annual operational carbon as a roadmap and comply with a minimum 40 points. So such project will be recognized as near net zero. And for net zero carbon, the criteria would change for the operational carbon, wherein more than 90% of the annual operational carbon should be offset. Of course, we have given a leeway of 10% here, because all said and done, the projects can do everything, but still there are certain challenges to offset operational carbon. Say, for example, by use of DG sets, we use the diesel, or we use CNG or LPG within the projects, or other sources. Even sometimes you want to source 100% renewable energy, it may not be possible. Of course, it truly may not be net zero, but is almost there. Even such project we are trying to recognize now, and even those projects need to comply with a minimum of 60 points. So what we are trying to emphasize is, out of these 60 points, it is very important for the projects to emphasize on energy, water, and managing the resources from materials and the waste. So such projects will be recognized under net zero carbon. And moving on to the projects in operation phase, what we thought is the projects are already in operations. There's a legacy carbon or residual carbon and embodied carbon. That's past. But what we want the projects to focus is the present and the future. So in that context, we are looking at operational carbon. So the strategies here would be how the project can implement energy efficiency measures so as to reduce the overall energy demand and energy consumption in the project, and integrate on-site and off-site renewable sources to reduce the overall energy consumption or source clean power, which in turn will reduce or offset the operational carbon, which is B6 as per the LCA stages. So such projects can be recognized under near net zero carbon and net zero carbon. So we have a checklist again on a scale of 100, where even in operation phase, we're encouraging the projects to have passive measures which can significantly reduce the operational carbon. So similar to design phase, we have in operations phase near net zero and net zero, wherein the thresholds will remain same, but we are not addressing embodied carbon. That's the difference in operations phase. So we have a case study here. I'll just want to inform Mr. Silverus, who will dwell more on this, but we were fortunate to have L&T Technology Center in Chennai to come on board as the first pilot project, and very recently we have recognized them under a net zero carbon design phase many good measures have been taken by the project to comply with this criteria. So I just want to share this information, and then I'll take a moment to emphasize that being in pilot and a carbon, a very complex subject and a lot more to be done. So we thought we'll take a step-by-step approach. So we're not trying to consider carbon in all aspects. There are certain things which were left, but we are aware that we are left, and these would be taken into account as we progress in terms of the availability of materials or the market adaptability with respect to adopting these concepts. So to name a few, in design and construction phase, we are not looking at interior and finishing materials as well as equipment systems, and also the emissions on account of use of DG sets or electricity or water during the construction phase or movement of people. And more importantly, we are not recognizing carbon credits or RECs. We want the projects to directly reduce the embodied carbon and also the operational carbon. Same holds good with operation phase. We have taken certain measures that we will not consider presently to have a step-by-step approach. But at the same time, projects which we take up these measures would be recognized duly in the innovation category. That's the approach we are looking at. So, I mean, this is not just for the net zero carbon. Over a period of time, I have said, mentioned in the beginning, more than 100 projects have taken up pilots in different categories. So what we're telling projects is take a step-by-step approach, or what is more feasible or applicable. Like for certain projects, water is more important or practically to implement. So we're suggesting those projects to look at net zero water, or project where there is more relevant in terms of energy, because again, energy with respect to the local policies, particularly from renewable energy. So wherever it is feasible, we're encouraging the projects to adopt the energy, water and waste to landfill rating systems, and then ultimately look at carbon. So these are few organizations, the leading organizations who have taken a leadership role in taking up the pilots. And having done the pilots, now these projects are scaling up across the they're scaling up across the country for their own facilities. And I'm sure over the period, we'll be working with all the projects of these organizations to make them net zero in all aspects, particularly net zero carbon. To sum up, ladies and gentlemen, there's excellent opportunity to demonstrate leadership in net zero. So we're looking at leaders who can benchmark the processes. And of course, we say, green buildings reduce operational cost, but let me share, the net zero buildings definitely can reduce operational costs. And of course, going net zero makes a business sense, all the more business sense, in fact. And more importantly, we are all contributing to India's commitment to become net zero by 2070. So with this, I conclude my presentation. Thank you. Sridatta, over to you. Sridatta, okay, I take this opportunity to invite Mr. Selvarasu to share his experiences, and in fact, he is one of the pioneers in the green buildings in India. Many of you may be aware, and we look forward to his views. Selva, sorry, I don't have your detailed profile, so I'll request you to briefly introduce and then start your presentation, please.
Thank you. I hope my slide is visible.
Yes, Selva.
Thank you.
Yeah.
Thank you so much, and thanks to IGBC for inviting me. I think some of the slides already Sambat covered, so my job is little simple. And if I exceed my time, please remind me, Sambat. Okay.
Sure, sir.
Yeah. My talk will be predominantly on the net zero carbon buildings, and basically talking about, I'll be covering predominantly on the L&T case study. Case study that is being the first net zero carbon building by design in the country. So just before that, I'm from, sorry, one second. Yeah, I'm from Lead Consultancy. We started 16 years back, and we have done more than 1,600 buildings, which are certified in the country and almost 7-8 countries and close to 600 million. That is our footprint in terms of work, what we have done for the last 16 years with around 180 people working in the organization in various locations. That's a simple introduction about company. So I'll be talking a little bit about LCA. I think already we have another expert will be talking about LCA. I will not go too much into LCA. And a little bit on the understanding of the building carbon footprint and what are the boundaries and how do that scope for LCA analysis. What is the methodology IGBC for really adopting to perform LCA? That's also a little bit I will cover since somebody already spoken. And standards governing building LCA, software used for LCA, and case study of L&T. So that's in a nutshell what I'm going to cover in next 15-20 minutes. Now, mostly all of you are aware, life cycle assessment, basically understanding 50 years life cycle of the building. I make a quantitative analysis to understand the impact the building is going to create on the environment in terms of CO2 reduction, then operational performance, water, energy, waste, all the resources which consumed by building, including embodied energy and carbon, how we minimize the impact on the environment for the entire the life of the building. We normally classify the building with about 50 years life cycle. It starts from, it's like a simple cradle to cradle, extraction, manufacturing, use case, then maintaining it for 50 years and disposal after demolishing the building or part of the building. The entire life cycle needs to be really analyzed to understand how the building is going to really have an impact on the environment tomorrow for the entire life of right from extraction, construction, operation and maintenance and disposal. When you look at the life cycle assessment, it gets into 4 critical steps. One is goal setting and scope definition. We need to define the goal, what you want to achieve in a building. And scope needs to be defined very, very clearly in the beginning. Now, most of you are aware how the scope 3 emission is very tough right now in the country to really perform the task. So we need to have a very clear scope definition that IGBC already performed the task. Then inventory analysis, we need to take a stock of all the building material, systems and construction, what we are going to do in the building. Then impact assessment through LCA. Then revisit the goal and scope and keep refining the entire process. This goes in multiple cycles to get the best result wherein you minimize your embodied carbon emission or operational carbon emission. When you look at carbon footprint, I think most of you are aware, it starts from manufacturing emission. It starts from extracting raw material from different sources, then manufacturing of product, what you need for your building construction, then the transportation, you need to transport from manufacturing to distribution to the building site. Then there will be a lot of emission happen during construction since we consume water, we generate waste, we consume energy. Then operational emission, for 50 years, we are going to operate the building. And also we keep renovating it in different periods of the entire 50 years of cycle. So there's a huge amount of carbon emission possible in the 50 years life cycle. Then end of life, it has to be demolished, disposed of, and something can be recycled, something can go to landfill. So that's what is very, very critical to plan in the beginning itself to minimize the landfill at the end of life cycle or during construction. That kind of material needs to be selected for the building to have minimum impact to the environment. This is how the whole cycle goes in terms of cradle to cradle to understand the carbon footprint. So we need to focus on all elements. It's not just a design or embodied carbon or operational carbon. We need to go to the entire cycle. It'll take some time. Globally, people are trying to get this entire thing stitched with the data, scientific data done once in the industry. And various system boundaries, you know very well. This again classified into A1 to A3 means raw material extraction, transportation, manufacturing. That comes in the manufacturing segment. That's up to the factory gate. Then construction, again, transportation, installation at site. Then B1 to B7 is basically a building construction, maintenance, repair, replacement, refurbishment. The entire operational performance will be clubbed. B1 to B7. C1 to C4 is end of life storage, like a demolition, transportation, waste disposal, all this stuff. The last D will be basically talking about how you recover and reuse and recycle once the building is demolished. So this is how the classification has been done for LC analysis. And already our Sambat explained about embodied carbon and operational carbon, what is the limit, how the number game will be on the IGBC rating point of view. I will not dwell upon this part. But when we talk about life cycle coverage of IGBC, we are talking about raw material supply, transportation, manufacturing, and building site, how we are constructing it. So that's how the overall A1 to A5 is covered in the current rating program. It starts from like a footing and foundation, structural floor, ceiling and roof assembly, entire system is covered under this category. This is how it has been taken care in the LCA analysis and net zero carbon scope. I think LCA process is so simple as that of other activities. Pick up the design and VOQ, extraction of data required, different component like a substructure, superstructure, pick up those material and analyze it, put in the software and see how we can optimize it by choices in terms of selecting different kind of material. If the current material is not really yielding benefit, then get into the lot of work on carbon reduction measures. I'll show you the case study how it has been done. Analyzing the proposed case, how we differ from or how we improve, how much we improve from the IGBC standard of 700, and then get into the reduction further. 700 is the upper limit. You will not be called as a carbon neutral. There are various other reduction strategy require up to 40%. Then the report submission. This is how the overall process goes. I think in the BOQ, I don't want to dwell too much on it. It talks about concrete use, then shear wall and substructure, superstructure, retaining wall, steel used in the substructure, superstructure, plaster type of plaster, waterproofing, facade glass. This is a major item in a typical core and cell building. Glass, then mortar use, cladding system, exterior wall, and various element material used for substructure and superstructure. So all these elements to be really covered in the entire quantification to perform the task. I'll just quickly run through the L&T case study. This is the first building taken up all kind of net zero activities, right from, luckily this project came up at the design stage to really innovate when we perform the task, which is in Manapakam, Chennai, you know, the L&T campus. This building is up right now, which is about 59,000 square meter build-up area, G+13 structure, and it's for their own use. This building achieved is going for IGBC, new building and health and well-being. It is the only building where we have all the program applied. In fact, we proposed and there is no resistance from L&T that this cannot be taken up. So we tried IGBC new building and health and well-being, which is under now the final stage. And this project achieved net zero energy, net zero water, and net zero waste by design, and also net zero carbon few months back. I'll not go in deep on net zero energy for water waste. I'll little bit focus on carbon. This building has got all the best efficient measure: chiller, lighting, glass, roof, insulation, wall, and EPI ratio is 0.73. That means 27% better performing than ECBC code, and window to wall ratio about 60%, and 250 kilowatt solar panel install. That's the maximum possible with available space, and rest will be procured as offsite green power. That's how this has been achieved, net zero energy by design. Net zero waste, again, same way. A lot of effort has gone into the building material and sourcing the material in terms of made to order. Then the waste is properly segregated and really taken for the recycling and reuse and manufacturing site for manufacturing product. On water, same thing. Huge activity has been done to increase the infiltration, efficient fixers, then treated wastewater usage, etc. It performed extremely well to get the net zero water by design. Now coming to the embodied carbon, once we performed our LC analysis, we did a lot of work, but there are some changes happen in terms of material composition. They agreed to perform. Once we perform that, we can change the material composition. So if you look at here, ready mix concrete, really GCBS cement has been used. It contributed 8,488 tons of CO2 reduction from normal ready mix concrete. Then I think you can read this reimbursement steel, ready mix concrete, glass about 30%, AAC block, aluminum frame, curtain wall, then pre-stressed steel for reinforcement concrete, cement mortar, ready mix concrete. So this how the whole, you can see the number, how much it is contributed to get this overall reduction in CO2 equivalent per year. This is what finally it has been done. It's achieved around 28.71 reduction embodied carbon from 700. This project achieved 499 kg of CO2 equivalent per meter square. And again, if you look at operational carbon, so critical that you need to have a projection how we are going to really manage. As I said, 250 kilowatt on site, and rest of the power will be procured off site. They have already agreement with the local electricity board. This is the number. If you can look at it, 499, about 28.71%. If you look at the kind of distribution, that is raw material, transportation, about material, about 87% contribution coming from material, transportation about 5%. I have seen a lot of analysis we did. What will happen if the material procured instead of Chennai, we procure from Delhi? So we did a lot of iteration for our own understanding. Whatever we transport across the country, not having major impact with the limit is not too large, about 4,500 kilometer. Transportation 5%, then replacement of 5%, waste about 2%, waste disposal 1%. That's how the overall composition worked out here in this building, if you talk about A to C4. And this is the kind of distribution of checklist. You can look at it right from the LC analysis, grain procurement, embodied carbon, 40 out of 40, and operation side about 28, totally about 78, and net zero carbon is 60. This project achieves 78, reaching the requirement or more than the requirement of IGBC to get the net zero carbon. So they are given a free hand L&T that whatever best possible, let us do it. Don't limit yourself to the number what IGBC has specified. And these are some of the element. If you look at it, what is the substructure element like Abraham wall, M10 and M30, solid concrete block, AAC, anti-termite chemical. These are some of the material contributed. Rebar still about 40%, 14% recycled content. And this, whatever I spoken already, this has been compiled here in terms of material composition to get this. These are the element really contributed material for embodied carbon reduction. And further, we analyzed it. Okay, let us not limit ourselves to achieving the embodied carbon. Is there any way to further reduce it? And due to techno-commercial reason, we are not proceeded further on the implementation. Yeah, these are some of the areas. Further use of AAC block in other locations. Gypsum lime plaster over cement plaster. Okay, that gives a better reduction. And M30 with recycle content of 30%. This would have been a little better result. Brick bed GOBA, nitrile rubber insulation over XPS has been used in the building. And rammed earth with the bond brick masonry gives a good result. And filler slab and jack are group with the conventional slab. So there is a scope. It doesn't mean that once achieve carbon neutral, and we can't say there is no further scope. So there is a possibility we can even improve further. So that's it from my side. Very short and sweet. Thank you so much. If any question, I love to answer.
Thank you, sir. Thank you very much for that wonderful session. So Sampath is taking care of all the questions asked in the chat box. So I think we don't have any further questions.
That's great. Thank you. Thank you. Any question? Because I have given my number, email ID, any participant. If you have something, you can write back to me. We'll have to answer. Finally, we need to educate, rest, and disseminate this for larger adoption in the country. Thank you so much. Thank you. Thank you for patient hearing.
Thank you. Thank you so much, Silva, for having.
So I think we'll go ahead with the next speaker for the day. So we have Mr. Harish Bora. So who is a subject expert in life cycle, cost and carbon studies within the building industry with 10 plus years of experience. So he is also an advisor in green building rating systems globally on LCA and LCC. So welcome, sir. Welcome to the webinar series day 5. So I would request you to take over and continue with your presentation.
Yep. Okay, let's do this. I think we're just doing another 20 minutes. I actually had quite a few things, but I think Mr. Silverasto has already covered quite a bit of it. So, and then Sampath, your presentation around it also is. But anyway, so I think when I realized that we have a 20-30 minute window, I think the main thing that I really want to kind of take you through is to this is the last session for the 5 days in a way, just to take you back to the first principles of what an LCA is, because I'm sure once you understand that bit, you will go on and find softwares and maybe even do your own on Excel sheets or whatever that is. But you need to be aware of what are we really calculating with LCAs and what does the framework look like, because then you'll probably have the right questions in your mind in terms of how to reduce that carbon. So I want to take you down that road. We could speak about ISOs, but that'll take hours, and we can dive deep. But this is just the first principle conversation on what LCAs really are. Yeah. Let me see if I can share my screen. Just a moment. Okay, I think there's a problem with me sharing my screen, to be fair. I can actually do the conversation without sharing screens also, but it would be nice if I could have my... Just one moment. Sampath, if I share something with you... Okay, I think let's just do the conversation. Are you guys okay with that? Yeah? I think
you can share the screen, sir. You can just press the share button.
I'm doing that, but it says my browser doesn't support it and I need to switch to a desktop app and things like that. And then it says problem processing your request, control contact number. It's okay, Sampath. I think we can do this. I think fixing this will take a longer time than just doing the conversation, right? Okay, so let me see if I can. Fair enough. Okay, so what I was really trying to get to was, it's a free-flowing conversation now that I can't show it, but please feel free to ask questions as you go along. and we'll do this back and forth. I'm really open to as many questions as you may have. So the whole idea of LCAs, so LCA has been around in use for a long time now. It's not a new thing at all. It was first used when by NASA for its all space missions. LCAs are basically nothing but frameworks on which you can understand the environmental impact of anything. LCAs are not designed for buildings. It's just like project management in that sense. It's a framework of thinking that helps you understand the environmental impact of whatever that it is that you're trying to measure, right? The building industry is, over the last few years, is beginning to adopt that framework for itself, which is why, and it's basically evolved to a place where this workshop is happening right now, right? Now, what the LCA framework really does is that it basically allows you to look at all the materials, whatever your system is. It could be a building, it could be a car, it could be a rocket, it could be a plastic bottle. It's allowing you to look at the materials and understand everything that's happened to the material before it came together to become the product, and everything that's most likely going to happen to the material after the use case is complete, in a way, right? So in this, so the LCA framework in itself allows you to kind of measure prominently about 9 main environmental impacts. There more as well. The one that you are most likely interested in, like as of right now, for your net zero carbon rating system with IGBC, is what we call the global warming potential. So what that really does is that it's basically a measure of how much greenhouse gas emissions took place in the different activities associated with the material. Just stay with me on this one, because if you understand this part of it, you probably get all of it more or less, right? So what it is measured, so global warming potential is what you're measuring on this IGBC net zero carbon rating system, and in most other rating systems around the world that are using net zero on buildings, they're focusing on this one environmental impact called global warming potential, not acidification, not eutrophication, because all those things can also be calculated using the same numbers in the same framework. We are interested in what is called the global warming potential. Of the nine different impacts that exist, global warming potential takes a leap in today's context, because most of this work that we're doing is in the context of climate change, right? It's in the context of the expectation that by 2050 the world will go net zero, the expectation that by 2070 India will go net zero. So it's in that expectation that these LCA frameworks are more actively being applied. And what net zero really means from a carbon point of view is nothing but finding a position where the amount of greenhouse gases that you have released into the atmosphere is equal to the amount of greenhouse gases that you would have absorbed, right? Because most of the greenhouse gases tend to be based on carbon. So in layman language, you tend to call it carbon emissions and this, but but the reality is you're basically measuring greenhouse gas emissions, which is why, irrespective of what software you use or however you do it, or whatever literature you read on LCAs, you will realize they call this GWP, they refer to it as kg CO2e. There's a small e at the end of it. So it's kgs of carbon dioxide equivalent. That E basically refers to the whole idea that you're not actually measuring carbon dioxide only, you're measuring kgs of carbon dioxide released into the atmosphere along with all other greenhouse gases released into the atmosphere, which is why that E is an equivalent. So the numbers that you're getting from these softwares or Excel sheets of literature is actually not for carbon dioxide alone. It's carbon dioxide, methane, it's nitrous oxide, it's all the F gases. So it's everything put together. It's just a common way of saying it, right? So that is what this LCA framework. So as you try and do IGBC net zero carbon, what you're actually measuring is global warming potential. It's expressed as kg CO2e because it tries to capture all the greenhouse gases that may have been released in associated with the building, in the manufacture, in the construction of the building, in the operation of that building, in the demolition of that building. So all of it put together, right? So that part of it. Now, what happens is, because the LCA study is on a building specially, is also sitting on the 3 stages to it, which was shown to you on the previous slide. So there's module A, there's module B, and module C. This is not, this whole idea of breaking down the whole building's emission footprint into 3 modules is actually not something that you'll find with somebody, say, if somebody is using LCA frameworks in the car industry, you would not find these modules. These modules don't exist for them. They have something else going on. These models don't exist for somebody who's trying to do these calculations for, say, a plastic bottle, right? These modules A, B, C, D, and D are exclusive to the building industry. It's how we're defining emissions. We're trying to break down emissions into different modules for our industry only. And the reason we do that, and the whole point of breaking down your total emissions into smaller chunks with definite definitions, is to kind of help you understand where in the process, like where in this whole process of cradle to gate, the biggest emissions are happening. Because you will end up in a situation once you do your study, you'll obviously pull in, you take the BOQ, you take in all the quantities, you'll probably model it somewhere, and it'll come up with a final answer, right? That answer in itself is actually useful, but it doesn't help you take that next step in terms of how do I reduce this emission now. To know how do I reduce this emission, you need to know where is the largest emission taking place to begin with. And that is when the module breakdown helps. Most of the softwares that you'll end up using today will have these breakdowns. So you'll be able to go back and see, okay, is my biggest emission happening in the manufacturing, in the transportation, or in the end of life, which is the demolition? Where is it really happening? Because the moment you know that answer, you know where to make most of your effort to find alternate solutions too, right? So that is why this breakdown is very significant, helps a lot. And if you like to do your studies in a very organized fashion, I would recommend that you also build your models with proper identifiers or however you want to call it for every element of the building. Because what that does is, when you start looking at the results, you not only start realizing that the biggest emission on my building is happening at the manufacturing, you also begin to realize, like was shown to you on the previous by this previous speaker, you also are realizing where is it the concrete, is it the steel, is it because you start seeing that bit as well. At the moment you have this combination of information that, okay, my biggest emissions are happening at A1 to A3, and it's probably happening at the substructure concrete, you know where to switch your effort to, because you're ultimately either trying to beat the benchmark or maybe hit a state of true zero, right? But you need to know where to go and hit, so that you spend most of your time prioritizing effort into the items that need your most attention. So that is how you will most likely want to use the LCA framework to go about doing it, right? Now with the IGBC, we're focusing on the whole idea that Sampath has presented to you is to capture the emissions happening at A1 to A4. What that really means is that all the greenhouse gas emissions that may have taken place in the extraction of the raw materials, the supply of the raw materials to the factories, the production of that product, and that taking that product from the factory to the gate of your construction site. So that's A1 to A4. And this emission that is happening, just to be fair, just to kind of make it clear, so there's never a doubt again around this, is that please understand this emission is not something that the material is doing itself, right? So that's like a thing that I hear once in a while. This is not so if you have cement, which has a carbon factor of say what X, right? It doesn't mean that the cement is releasing greenhouse gases into the atmosphere. What it really means is that all the activities that went into making the cement released that greenhouse gas. And how that really happened is basically the whole story of fossil fuels, right? So every activity, if you think about it, right from the beginning, which is the extraction of raw materials, how do you think this is happening? This is happening with large machinery. What do you think is driving these machines? Like how do these machines even get the power to do the job that it does? It burns some form of fossil fuel, most likely diesel or petrol, right? It is that burning of petrol or diesel, because fossil fuels are nothing but compressed carbon, right? So the moment you burn fossil fuels, the carbon attaches, burning is nothing but oxygen. The moment you attach that carbon and oxygen, you get CO2, carbon dioxide, and the other greenhouse gases, right? Which is really, and you get a lot of energy. It's the same logic that applies to your cars, your scooters, and everything else in that sense, right? So what's happening is every activity. So how is the raw material moving from the extraction side to say the place of production, it's on some vehicle. What do you think? How do you think this vehicle is finding its energy? It's some petrol or diesel, which is a fossil fuel. How do you think? So what happens in the car? There's a combustion engine that burns the fossil fuel. The moment that burning happens, the carbon of the fossil gets attached to oxygen at the burning process, releases carbon dioxide and energy. The energy is used by the car to move forward, whereas the greenhouse gas is released from the exhaust. And this is happening across. So if you look at any stage of the building life in this whole life cycle principle, you'll see this happening again and again and again and again. In fact, B6, which is basically operational energy, right? What you're really measuring there from a carbon point of view is how much of the energy coming into your building was actually produced through the process from fossil fuels. That's really what you're measuring from a carbon point of view, operational energy. So in India, I had a thing open that I cannot show right now, but in India right now, as of today, right? As of today, about 56.8% of all electricity is coming from fossil fuels. 49% of this is coal alone, which is basically thermal power plants. And then the other 43% is coming from renewables and nuclear, which means that this 57% that is roughly coming from fossils, what is happening at those power stations is that there is some amount of coal being, let's take, for example, the coal thermal power plant, right? So coal is being burned to produce tremendous amount of energy. This energy turns water into steam, moves a turbine, and then electricity is generated, which is then transferred to your homes, right? That action of burning the coal to produce that energy is nothing but fossil being burned, which is basically carbon attaching to carbon, oxygen, carbon dioxide being released. So that carbon dioxide that was released at the thermal power plant is actually, and that is coming to you, to your building, is actually what you're capturing in B6, right? So if a state arrives, say, where India is no more touching, fossil fuels for electricity generation, then you also hit a situation where the building may be drawing a lot of energy from your kilowatt perspective and this and that. That's your function of design, how you do it. But from a carbon point of view, the building would have zero operational carbon without doing anything because the grid itself has become clean, right? So what's really happening here is when you're doing an LCA from a carbon point of view, you're basically asking yourself one question: is that where is the energy needed in that activity? And where is that energy coming from? If it's coming from fossils, there is going to be a carbon footprint. For example, if I just go back to an example of transportation from, say, the extraction center to the factory outlet, imagine that same activity now happening with a man on a bullock cart taking that item. Now, when that happens, there is no, so then that whole activity has zero carbon footprint, because in that exercise of carrying it manually, there was no fossil fuel being burned, there was no carbon dioxide being released. So it'll have zero carbon footprint in a way, right? So imagine it like just to push the envelope of thinking. Imagine like a palace that was built in the 16th century, and let's say everything was done manually. Like laborers on the floor were literally cutting every slice of stone. They were putting it without any machines that needed to depend on fossil fuels. That whole building would have been created with zero carbon footprint. Right? Just absorb that for a moment, right? So it's like we've always done it until we've discovered. So we've always built zero carbon footprint buildings unless we've discovered fossils and we've learned to use machines that can depend on fossils to make our lives better, quicker, and all that stuff, right? So now what we're trying to do is we're trying to reverse that. So either you are making it as energy efficient as possible so that less energy you need, the less amount of coal needs to be burnt on the thermal power plant, and less carbon footprint is borrowed by your building. Or you're trying to find a completely alternate way, remove your building from the grid, or go for materials that were non-manufactured. Say cement and steel, if you just noticed, were shown on the L&T project, cement and steel had very high numbers. They showed up very high up on the list of embodied carbon, right? And that's not necessarily because of the project itself, because steel and cement manufacturing itself heavily relies on burning fossils in the manufacturing process. And when we really haven't got around that process yet. I mean, there are many clever innovations that have come up, and And I'm like EAF, what we call the EAF, which is electric arc furnace, is the most popular at scale production of steel with very little carbon footprint because there's hardly any fossil in the production process. But largely, traditionally, these manufacturing processes, since their innovation, since their first invention, have remained the same, which is heavily dependent on the coal for the energy, right? So cement, for example, cement itself has a very high embodied carbon, but that's not because of what's really, like, if you really go behind the scene on cement manufacturing, you'll realize that there's a step where they produce something called the clinker. To produce that clinker, all the raw materials are basically smashed, powdered, and then heated to a temperature about 1500 degrees Celsius, 1500, 1600 degrees Celsius. Now that temperature, you're almost unable to hit that temperature unless you're burning a lot of coal of sorts, like the traditional way of doing it. So they would burn a lot of coal to melt the raw materials, and then the raw materials will melt, a chemical reaction take place, and what you get is clinker, which is then mixed with gypsum to give you cement, right? Now, everything about the cement manufacturing process before and after that step where they melt the raw materials in a way has a very low carbon footprint. Like, there's hardly an emission happening. But that one step alone makes sure that cement production has cement at the end of that whole process would be responsible for a large amount of emission, just because of that one step in between. So if you're a cement manufacturer and if you've done your LCA, you know that is where the problem is. You're trying to solve for that process. Now, as a building industry, as architects or as engineers that are trying to design buildings, you're looking for manufacturers who figured how to produce the same cement, but in a way that clinker step demands less energy or has less emissions going on at that level. So it's that sort of, so if once you know that, like, why a particular material has emissions on it, you will know how to find your manufacturers also, because you would have those individuals who are telling you that this are, so the same reason why natural materials like stone, for example, would have a very low carbon footprint to begin with, because stone did not need any manufacturing. You've literally, like, there is emission that took place in the extraction, but it's not as high as the other ones. And there is hardly any processing apart from you're cutting into slabs. There is emissions happening there as well, but it's nothing close to the emissions that are happening in the manufacturing of, say, cement or steel or, say, aluminum or any metal for that matter. Any metal is extremely processed, like demands extreme processing, large amount of fossils and energy in the manufacturing process, and hence has a very high carbon footprint. The same story for glass, the same story for cement. And the unfortunate nature of our industry is that we land up relying most of the, like, we're largely relying ourselves on these materials. So some other industry that does not use cement, for example, already has the advantage of the fact that they don't, like a car would have a lower carbon footprint than something similar in the building industry, because car by default is not using cement. But for the building industry, what's happened is we are actually falling back on some of these very high emission manufacturing processes for our products, which is also why you see you'd see it in IGBC's rating systems and across. They're constantly pushing for sustainable products and, like, local products, because usually they would not go through that amount of manufacturing in that sense. But I'm kind of happy to take I just really want to take you down that road. The fact that what you're really measuring, when you finally land up with a number saying that the building has a carbon footprint of, let's say, 499 kgs per square meter, what that actually means is that it doesn't mean that your building is releasing that amount of carbon dioxide. It only means that everything before the building, all the products that came to make the building, and all the things that will happen to the building as it goes into operation phase and in the end of life phase, is likely, all those activities will fall back on some form of machines. Those machines will fall back on some form of fossil fuels, which is petrol, coal, diesel, natural gas. And as you burn those fossil fuels in those different stages of life or wherever that is, some amount of carbon dioxide will be released. So you're really calculating the potential of how much carbon dioxide will probably be released if this building is constructed and operated for 60 years, 50 years, depending on how long you really want to do the LCA study. Yeah. I'm happy to take questions if you have any. There were a few things that I wanted to show, but I think it's okay. I think I really want to fall back on the first principles. I'm looking at the chat box also. So if you have anything, I'm happy to kind of take you down. Difference between net zero carbon and carbon neutral, please. Okay, so to be fair, these are all spin-offs of the same core concept. Yeah. So let's just for a moment, just understand zero carbon and net zero carbon, because that I think then that will kind of answer a lot for you. Zero carbon is basically to say that there is no greenhouse gas emissions, right? Net zero carbon is basically acknowledging the fact that there will be emissions and there's no way that we can bring it to zero immediately in the near future. But what we will do is that we will try and reduce this emission as much as possible. But whatever we are left off, we will try and do something outside, which is basically you're trying to go to a carbon offset market to kind of buy carbons, or maybe a forestation plan. And so you're basically you're calculating carbon, you're doing everything possible, sustainable materials, local materials, your all the transportation is EV. Well, let's say everything you've done, you'll still be left with some carbon, because at this moment you're still falling back on cement, steel, glass and all that, right? So whatever the value is that you're left with, you're trying to find another project somewhere through a carbon market, or maybe your own project, where they are absorbing carbon dioxide and greenhouse gas from the atmosphere, right? There are many technologies that exist. So the most natural basic one is plantation, obviously. Plants absorb carbon dioxide for photosynthesis to make their food. That's the most natural. So which is why if you release 10 units of carbon, say, per year, can you buy enough trees through a carbon market, or maybe do your own plantation that's going to absorb 10 units of carbon dioxide per year? So that's net zero. It's just a mathematical way of doing it. The reason net zero is more popular than the idea of zero itself is because of this realization that we cannot hit zero right now, because our entire process, the entire system, not only for the building industry, just the way the world functions, is entrenched with fossil fuels, and we will take time to kind of transition away from fossil fuels, and that might take 20 years or 30 years. The whole the whole thing that the Paris Agreement calls out for in Article 3 is the fact that if we manage to hit a state of net zero, which basically means we will still be emitting carbon dioxide at the year 2050, but if we can find enough sinks that will absorb the carbon dioxide, then there is a chance that by the year 2100, which is the end of this century, the increase in global warming will be, the upper limit is going to be 1.5 degrees. Right, so that's the big plan on which the whole climate movement is working, on which all these LCAs are functioning at this point. So net zero is just an intermediary way of something that we want to hit by 2050, because after 2050, the idea is to now move towards the actual zero. But first we need to hit a state of net zero, which is the year 2050, as of right now, agreed between all the countries. Let's look at what else you have. Someone is looking to buy. Okay, someone is, thank you. Someone is willing to buy 1 lakh credits through us. Can you help? I don't think I'll be the best person for that, to be honest. I can help you connect with a lot of friends who probably. Software for LCA analysis. Okay, so I think software for LCA analysis, there are quite a few, right? The most popular one is right now is one-click LCA, but the other ones that I can point out is eTool. That's another one. But if you really had your bandwidth, and if you really think you can work around with numbers, I would recommend playing with it on Excel sheets, to be fair, because these are just mathematics that is happening. There's like on your 3D renders, there's much more like design happening. But LCAs are nothing but mathematical calculations at the end of the day, right? It's just how much petrol has been burned, how much energy, how much greenhouse gas has been released, and you're just summing them up in a way. What one-click LCA has done, or say what eTool has done, is the fact that they've tried to make the software user-friendly from an architect's point of view, so that you don't have to go behind the scene on all of that stuff. You can just say, I have 20 kilograms of cement and say 40 kilograms of steel, and they do all the background calculation. So but having said that, we want to just put it out there that none of these softwares are perfect right now. So use them with a pinch of salt, because we can do this conversation forever, but they are also improving because there's so much data out there that needs to be captured and averaged out. So I would recommend that even if you use the softwares, use it, but when you're looking at the answers, that's been thrown back at you, If you know how to read the answers, you will probably pick up where the errors are, and nothing stops you from fixing them beyond the, like, you've downloaded an answer sheet. Nothing stops you from doing further calculations on top of it to actually have a perfect number for your building. And you'll see it when you use them. It's not to say that they're lazy, or it's just that they're also progressing. They're also trying to understand the need of the building industry and how that can be done. But these softwares are not 100% what you would want them to be. Today, you still need to do a lot of post-analysis once you've downloaded results from these softwares. Okay, I'm just going to leave my email ID in case someone wants to pick it up. I think that's another one. You can find me on LinkedIn. I think that will be one. Could you please share your, okay, contact details. I think, so my email ID is quite simple. It's mail@harishbora.com. Feel free to reach out whenever you have to. Just for aesthetic purposes, nowadays companies are constructing glass buildings and further. Okay, so that example, there's an example here for aesthetics. Nowadays, companies are constructing glass buildings and further set their AC to 20 degrees and everything. That is true. That is 100% true. Because two problems are happening there. One is, see, glass in itself has a very high embodied carbon. It's actually one of the worst case scenarios of materials with high embodied carbon. What the glass industry has done on the other side is that it's come up with a lot of innovative solutions to help you reduce the operational energy. Right? It says that they have reflectivity and this, like all that stuff, good stuff. But all of that helps you reduce B6, which is the operational carbon, but it does not help you at all to reduce the embodied carbon of glass, which is the amount of emissions that was released in the manufacturing of glass itself. There's nothing like that. So when you do your LCAs on materials, and as you punch in glass, you will see how much they stand out. Yeah. So I'm like, for example, a classic, like, say you're using a triple glazed, glazing system because you want to reduce operational energy. It's going to reduce your operational energy, no doubt, but it's going to spike up your embodied carbon like crazy, right? So I think a good LC analysis would be to see how much does it bring my operational carbon down and how much does it spike up my embodied carbon, and to see because if there's a net increase, then it's not really it's not really a solution. If there's a net decrease, so the decrease in operational energy is far more than the increase in embodied carbon, then I think you're good to go. I'm like, it's at least something. I think that's the way to look at it. I think that would be the way to look at it. Any other question? I'm happy to take them on. I've basically been doing these studies for a long time now, which is why the insights, most of these things that I'm telling you are actually just from experience. And if you have not done LCAs yet, and if you go about doing it, trust me, with every LCA that you're doing, you probably get better and better and better and better. And at some point, you reach a point where just looking at the BOQ, you'd probably know what number this is going to hit, more or less. It's just a function of doing it. It's just a function of keep doing it as frequently as you can. And also, as a suggestion, it'll be very nice if you plan to do LCAs as a thing, in your career, or as a consulting service or whatever that is. See if you can spend some time understanding how these different materials are manufactured, because you will understand exactly where the emissions are happening. Because the moment you know that, you know how to find the alternate material. Yeah, so I mean, it's as simple as that in that sense. Why are we going away from indigenous? I mean, like, that is a sad state, but that is, I'm like talking about indigenous ways of planning and designing. That's true. I think IGBC, I think all rating systems emphasize on that. The catch with the indigenous is that you're falling back on local materials, and I think I live in Bombay, but I'm from Assam. So this thing called the Assam house that we used to have was very well ventilated, right? It was very high roofs, cross ventilation. I mean, like, all the new buildings that are coming up are not that. It's more like the houses we see in Bombay. No problematic with it, but it's not as efficient as that used to be. It's just, I mean, like, it's just, I mean, like, if you're aware of it, maybe go and tell others to be aware of it. But it's just a sorry state of how things are. Is sufficient data available for MEP equipment to include them? Yes, there is sufficient data, but not in great detail, but sufficient for you to understand what the MEP embodied carbon is going to look like? Because I think that's a valid question. As you bring in, like, say, a certain kind of HVAC system or VRF system, whatever, is going to reduce your, it may or may not reduce your operational carbon. Yeah, most likely it will then, which is why you're trying to do it. But you need to know what is the spike on the embodied carbon, because you're introducing a new material to the project now, which also means that there is new emission that will be allocated to your building, right? Because your HVAC would have steel on it, aluminum on it, copper wires on it, so all metals. So there is going to be an embodied carbon of that machine coming into your site. So it's worth knowing, like, if the reduction in operational energy, operational carbon, because of that new technology that you're using, is more than the increase in embodied carbon that makes that machine in itself. Yeah, can you suggest some reputed certifications? Okay, so the LCAs, there are a little, the whole thing with LCAs right now, and I could be wrong, this is my understanding for the last, like, a few years. There is, like, we do a program at, I do a program at IGBC, and we do a three-day program where we dive into LCAs just from a building perspective. But these programs are really far and wide. I am thinking of kind of taking this forward as a thing. But these programs are really far and wide, and I do see a lot of, like, when you talk about LCAs, not necessarily students, but even professionals, I think there's a lot of confusion. I realize that people are looking at product LCAs, they're looking at product LCA ISOs and applying them to building LCAs. Building LCAs are different from product LCAs, and there are many things, like the many other things technically, if you really want to dive in. I'm a little sorry, I don't, like, apart from the program that we do at IGBC at this point, and far and wide, once in a while you'll see somewhere else, the very few, I think it's a function of you doing it in a way.
Mr. Harish, I would like to pitch in there. So regarding the LCA course, so upcoming event of IGBC, the flagship event, Green Building Congress, which is happening in Bangalore, on the day, last day, on 16th. So IGBC is offering a full day LCA course. So I would share the course details and everything with all the details to all the participants today.
Yeah. So I mean, it's a little far and wide. I think these sessions that you're attending right now are like the first, the first proper ones of their kind in a way. Today, my idea was just to kind of show you roughly what that world looks like, the whole world of LCAs. If it interests you, I'm hoping you'll find your way along this journey, in that sense. But all things said, this whole idea of net zero carbon, you cannot hit net zero carbon in any industry, including the building, unless you're calculating the carbon, right? And the only way to calculate that carbon right now, or that it's always going to be the LCA framework. There's no other way. So the whole idea of, like, you can go in any direction. You can go to the carbon markets. You can go wherever you're going, basically, across industries. If the whole idea is for India to hit net zero carbon by the year 2070, you cannot do it without calculating your carbon footprint. And the only way to calculate the carbon footprint is this framework called the LCA. Are CCS technologies being used in cement manufacturing? Yes. So basically, okay, so this is a question, I'm going to just bring it up. The question is, are CCS, which is basically carbon capture technologies, being used in cement manufacturing facilities as per your information? What impact does this have on the building LCA calculation using the cement? Okay. So just for everybody else who's just probably new to this term, so CCS, so that's the natural way of absorbing carbon of greenhouse gases from the atmosphere is by plantation, right? Because trees absorb carbon dioxide for photosynthesis to make their food. So, but naturally they go about doing this thing, right? What's happened with this whole ambition of wanting to hit net zero by 2050? I'm like, not really wanting, you have to in a way for the Marshall Islands in many senses. The tree cover of the globe as it stands right now will fall insufficient to capture back all the greenhouse gases that we've emitted in the last 150 years. So there is a need for some form of technology to also complement the forestation to suck the carbon back from the atmosphere. These are called carbon capture technologies, right? There is another way of looking at this, is that some of these so that's one technology that exists. Another technology that exists right now, these technologies, by the way, they exist, but they're not financially viable yet. So a lot of factories will not use it. The other thing that there's is that most of these, if you look at any cement manufacturing unit or steel or like any manufacturing unit, you'll most likely see a big nozzle, which is like your classic interpretation of what the industry is. And on the top of the nozzle, there's a lot of greenhouse gas being released, smoke being released, which is basically greenhouse gas in those cases. They come with technologies to cap the carbon right there. So they put a filter on top of that fossil. They will continue to burn fossils to manufacture the cement the way it's traditionally been done, let's say. But as the greenhouse gas, as the coal was being burned, as carbon dioxide and greenhouse gas was being formed, they would start releasing it through the nozzle. But now, instead of releasing it into the atmosphere, they would cap it there. So there's a machine that they put it there, a carbon capture machine that captures the carbon dioxide and greenhouse gases before it's released into the atmosphere, right? So for industries that are technically called hard to abate, which is basically industries where it'll take us a lot of innovation to reach a point where we will probably be able to manufacture them with less emissions, steel and cement being classic examples. These are called hard to abate industries. These industries usually fall back on this technology because they don't know how else to manufacture without burning the coal. But at the same time, can we at least prevent the carbon dioxide from releasing into the atmosphere? Now, I don't think this is being used at scale in India yet, right? But if it was to be used, then your LCAs would drop, because in that case, your A1 to A3 numbers would drop. Because going back to the first principle, what you're really calculating is the amount of greenhouse gas emitted into the atmosphere because of that manufacturing process. If the emission is prevented, then the carbon number dropped too. And this is what I was telling you about the first principle, because if you start thinking about how much coal is being burnt is giving me carbon footprint, that's wrong. How much energy is being used to give me count, that's wrong. What you're really calculating is how much greenhouse gases are being emitted into the atmosphere because some coal or some oil or some petrol was burnt in some place, right? Okay, so nature-based solutions are always the best ones, no doubt. I think the fear with like the whole argument of CCUS and nature-based solution is forestation. Let's accept that. And the whole argument between forestation and CCUS is the fact that CCUS is another tech. Like when industrial revolution happened, when we learned to use fossil fuels to run our machines to produce in mass quantities, we did not know that the fossils would land up releasing greenhouse gases. So like, you can't go back and blame the first, like, the first factory saying that you guys knew that you were, they did not, they were just generating energy. At some point in this journey, yes, we realized that all that fossil that we were burning inside factories were releasing greenhouse gases that was causing this greenhouse gas effect, that was causing global warming, and it was causing climate change. But until that point, you did not know what was happening. So nature-based and CCUS, I think that's the thing with CCUS is the fact that the argument for the anti-CCUS argument right now is the fact that it's another technology that we're going to fall back on to prevent, say, global warming. And we don't always know the full extent of how a technology plays out, which is exactly how the first steam engine, they were all running on coal. The first steam engine was running on coal. So our entire idea of modern world is basically to make machines that run on some fossil fuel, coal, petrol, oil, diesel, right? And at that point, we didn't know the full extent of what that would mean. And CCUS, that's the counter argument to it. But I don't see how nature-based solutions alone will help us now, considering we've emitted so much greenhouse gases in the last 150 years. In fact, it's increasing every year. It's only in the COVID years, 2021, when there was a drop in the global greenhouse gas. That's because everybody was in-house. There was no manufacturing happening. What do they do? I think this can go on. I can keep doing this, but somebody, do you want to come in? What do you do after capturing the gases? What do you do after capturing the gases? When you capture the carbon at the top end, there are two ways that you deal with it. One is you capture it and you try and find a way to make something out of it so that there's a business case for that capturing. Because right now that capturing is not a business case. It's just capturing for the sake of preventing it from kind of, escaping. And a lot of companies would do it wherever they're doing it because more of their responsibility towards the environment and because of whatever policies that they bind under to reduce that emission. But there are enough experiments going on right now on what can you do with that carbon once you capture it to produce something and maybe create a business case that kind of allows you to invest money to build that tech to begin with. But the most common way of handling this is what they do is coal, oil, natural gas are all fossils that are found deep inside the earth. They dig them out, and that's how the whole modern world is running. What's happened in the last 150 years is that there are now holes inside the earth where this coal, oil, natural gas existed, and you've completely dug them out, right? What they're trying to do is, and they've done it successfully, they're trying to take this carbon that is captured in the nozzles, and they're trying to drill it back because those pipelines now exist. The same pipelines that brought the oil up or the coal up can be used to reverse the carbon back into those so that they can become fossil for another thousands of years in the future. So these are different techs different ways that are working on this. Some of these technologies are proven. It's a question of financial viability. Who's going to pay for it? Is the government paying for it? Is the corporate paying for it? So it's really got caught up in the world of capitalism of that sort. But the technology now exists. It's a question of at what scale and who's going to apply it and things like that. Some of these technologies are already at play in Europe right now. And the government and all the countries have come together, pool money, and have kind of go ahead doing it.
So, thank you, Mr. Harish. That was a wonderful session, and there is it's been a lot of interaction
this can really
from
go on. This can really go on.
participants as well. So,
I'm going to leave my email ID once again. I'm sorry I couldn't show my slides. I didn't quite have slides, but I had a bunch of things that I wanted to show. But I think it is what it is. Find me on LinkedIn if you want to. The other place is all good. And yeah, and happy to kind of keep in touch. And Sampath, thank you for this whole session. I think these are very useful sessions to have. Yeah. I think I'll leave it to you guys now.
yeah. So, thank you all the participants. So, the 5 days webinar session has been very wonderful. It's a wonderful session and very interactive, especially today with all the discussion on LCA and net zero. I think we should be coming up with more net zero and LCA based approach sessions.
Absolutely.
A lot of participants interested in those things. So I will be sharing the LCA course details which IGBC is offering with all the participants definitely. So you can go ahead and look into that. So on this note, I would like to end the webinar here.
Thank you.
Yes. Thank you very much. Thank you very much, Mr. Harish.
Thank you, Sampath, and to the CII team. Bye-bye.